Okay, a very good evening everyone and welcome to the chemistry class. So, Kohima Center is there and this is the, I guess, the very first class of yours of the chemistry, right? So, Kohima Center, are you there? You people, you know the things, right? You have sit in the other classes also. For the chemistry, you people have the first class right now. So, you can just use this chart system. I am very much able to see your comments here. Okay, very nice. So, Kohima is there. How many students are there at the Kohima Center? Can you just share your number? And I was just saying that for the, okay, 9 students are there. Very nice, very good. So, you people like chemistry? This is obviously going to be different, something different from your 9th and 10th standard. But you have tasted some of that in the 9th and 10th obviously, okay? Okay, you like chemistry, that is nice. Let me tell you one interesting thing, like you people have studied the chemistry in your junior classes, right? And you know, for the chemistry from now, from the 11th and 12th, we will be having the divisions here, okay? You will be going to study the 3 types of the chemistry. The one is the physical chemistry, the another is the organic chemistry, the other is the inorganic chemistry, okay. So, we have, let me write here, okay, so you will be getting the idea. So, first of all, obviously we have to understand now that what we are going to study. So, for the chemistry, let me tell you that we are having the 3 divisions here. So, we will be having the physical, we will be having the inorganic chemistry, and we will be having the organic chemistry. And if I talk about the, you know, in your school exams, like in your board exams also and in the competition also, you will be able to see the mixture of all these 3, okay. If you have checked your NCERT or you are following any other book, you will be seeing that all of the, you know, the chapters are actually the combination of these 3 types. So, physical is there, inorganic is there and organic is there. Anybody having any idea? Obviously, these are the technical terms, okay. I will be giving you the idea in the layman language, but do you people have any idea? When I say that we are talking about the physical chemistry, or what we study in the physical chemistry? Anyone, anything? I would be happy if you share your answers here on the screen. It would be great, you know. So, what type of chapters, or instead of the chapters, what is actually the study of the physical chemistry? You have any idea, Kohima Center? What do we study in the physical? Yes, any one of you? As you know that there are no cameras there, I am not able to see you all, but the only way of interaction we have is that screen, okay, that chat system. So, just fix your hands on that keyboard. Any one of you, 9 students are there in the Kohima. Anyone having any idea? If you have the idea, just write it down, and let's say if you don't have the idea, just write down, ma'am, we don't have any idea. And although you people have studied the chapters in the physical, you know, in your junior classes. Anyone? Kohima Center, any idea? Okay, I'll tell you. You people have studied the matter, right? In your 9th class, there was a chapter of the matter surrounding us. You people have studied the chemical reactions, the chemical equations, all these kinds of things. You know, whenever we are talking about the surroundings, okay, that all comes under the category of the physical chemistry. When let's say I am saying that I have an acid with me, I have a base with me, I am doing a reaction in the lab, okay. Or let's say we are producing any new chemical, or we are checking the chemical properties of any chemical, anything, okay. So, obviously, you talk about the concentration, you talk about the dilutions, you talk about the, you know, let's say there are the certain mixture of the gases, you talk about the reactivity of the gases. All these kinds of the things comes under the category of the physical chemistry, okay. And if I talk about the inorganic chemistry, what is the inorganic chemistry? Anyone, any idea from the Kohima Center? You are the only center with me, obviously, so I will be again shouting for your name, okay. So, anyone, any idea for what is the inorganic chemistry? And you have studied these things related to the inorganic chemistry in your previous classes. So, Kohima, any idea? No idea, ma'am. Okay, don't worry. So, have you people have seen, I guess, in your schools, in the science laboratory, just check that there is a big, huge table will be there. Periodic table you have seen, right? And you have studied the periodic table. Have you studied periodic table earlier in your junior classes? I hope so that you have studied it. Because obviously it's there in the NCERT. If you are following your state board or the state books also, obviously that chapter will be there. So what is that Kohima Center? You people talk about, let's say, the reactivity, okay. Let's say I say that I want to study sodium, okay. Then you say you want to study the properties of the iron. You want to study about the noble gases, okay. So all those elements which are there in the periodic table, and when you study the properties of those elements, that all comes under the category of the inorganic chemistry, okay. That you are talking about any one particular element, and you are talking, let's say I want to check for the melting points, boiling points. So the study of one particular element, okay, all these things comes under the category of the inorganic chemistry. Now I'm sure that you people will be having the idea for organic chemistry. Anyone? What is the organic chemistry? Obviously, it's the so common term, these days it's a so trendy terms. We used to say that we are eating the organic food, and we are being so healthy, and we just say no to the junk foods. Is that so, Kohima Center? You people like healthy food or the organic food? We call it these days, see, this is the particular thing, like organic farming is there. Something related to the carbon, okay. When you talk about the carbon, when you talk about the compounds made up of the carbon, all these things comes under the category of the organic chemistry, okay. So I hope now you got the little bit idea. If anyone says to you that what chapter you are studying, you are able to tell them, see, we are studying the physical chemistry or we are studying the organic chemistry. Is that clear, Kohima Center? Anyone? Any doubt, or if you want to add anything, just feel free, Obviously, this is the first class, so we will be having the more interactions today. Clear? Okay, that is so nice. So, before starting the class, you were able to see the screen there, you were able to see my name there, and you were able to see the chapter name there. So, the very first chapter in your, for the chemistry of the 11th is the mole concept. So, later on we will talk about that more, and that is actually the chapter of that physical chemistry, okay. And yes, I can explain the inorganic. What I am saying that majorly, if I talk about the 11th, your major chapters are covered for the physical chemistry. Like you people will see the, with the chemical reactions there. In the mole, we will be talking about the chemical reactions, okay. We will be talking, let's say I want to take, let's say this is the glass of the water. Let's say there is some acid in this glass, okay. And I am saying that I don't want that full glass of that particular acid. Obviously, I am not drinking the acid, but I am just taking an example, okay. Let's say I need to define something, that let's say I am taking this much concentration of that acid, okay. I want this acid, like how can I define it? Either I have to say that I am taking the half of the glass of the acid, or I will be taking that, I want the 10 ml of the acid. I am saying that you need some dimension to define that what quantity of the acid you are taking for your reaction, okay. So all these things we will be going to study in the mole concept. Atomic structure is there, equilibrium chapter is there, all these chapters comes under the category of the physical. Now you people are asking me about the inorganic chemistry. Look at the screen. In the inorganic chemistry, as I told you, we majorly talk about the periodic elements, or I should write the periodic table. In the when I say that I am talking about the study of the metals, or let's say non-metals, the reactivity. So all these studies comes under the category of the inorganic. When you are doing the studies of the metals, of the non-metals, or you are talking about the reactivities, or some of the other properties. Here also there will be other different properties. There are the certain physical properties. Physical properties is like how the particular element looks like, how it is acting physically. And I can even talk about the chemical properties. But here where our main concentration is for the elements. Our main concentration of this is for the elements. Okay, when you pick any particular element and you talk about their study. Okay, so let me give you an example. Let's say Kohima Center. Can you tell me one thing? You people have seen the periodic table, right? You people have seen the periodic table. So what is the use of that periodic table? Why the hell they have made that table? Why they cannot simply randomly study, and why particularly they have fixed the position of those elements? Any idea you people have? Why we study periodic table? Or what is the what is the necessity? What is the use of studying that particular periodic table? Anyone? Because this best can be explained with this example which I am taking. You have any idea, Kohima? It shows the atomic number. Okay. Anyone, any other student want to write anything? You are saying that we are studying the periodic table that because ma'am we are able to see the atomic number. Obviously you are able to see the atomic number there, you are able to see the molecular weight there, or I can say that mass number there. But what else? Anything you find different? Any other reason anyone want to try? Just feel free to write. Okay, just feel free to write, any of the student from the class. No? No idea? Okay, let me tell you, like if I talk about the, later on we will study, okay? I am just writing the few things here. I have just taken the one, I'm not going to write the complete periodic table here. I am just writing the one series there, okay? One group here. Like lithium is there, lithium, sodium, potassium. Lithium is there, sodium is there, potassium is there, rubidium is there, and below it is the cesium. Okay, I am telling you what is the use of the periodic table. Why we are we are specifically studying the table in a particular pattern. This is the reason because let's say there are so many elements in the periodic table. You know that 119 elements have been discovered so far. Okay, so let's say if I want to study all of these elements which I have written on the screen. I want to study all of them. Let's say any one day you people want to study all of them. Suddenly you got so much interest in the chemistry and you are saying no, we want to study all of them. Okay, so let's say you pick the sodium. Okay, so what is the beauty of the periodic table is that they have arranged the periodic table or all the elements in such a way that if let's say I spend one night in studying the sodium in studying all of the properties of the sodium, physical properties, chemical properties, everything let's say I have studied for the sodium, then all of these properties of the sodium will be matching, they match with the other rest of the compounds. Okay, so let's say if I have spent one night for the sodium, it means I automatically get to know about the potassium also, I get to know about the rubidium also, I get to know about the cesium also. Okay, so this is how like typically they are fixing the position. Okay, later on when we will study the periodic table chapter, it is there in your syllabus. This is the chapter number 3, then we will learn more. Okay, so this all studies include into that inorganic chemistry. Okay, you are getting the concept right, Kohima Center, that if let's say I study the sodium, I will be getting to know about the properties of the other elements as well which are below to it. Okay, so that is why like the properties resembles with the other element. This is how they have fixed the positions there. Okay, so this was all about this particular specification which I have written, the physical, inorganic and organic. Now coming to your 11th class, what is happening in the 11th, as I have told you that your major topics will be covered in this physical chemistry. Okay, So people, those who like numbers, those who like doing the calculations, they will love to study these kinds of chapter. But I know that there are certain type of people, those who don't like maths, we hate numbers, we don't like it, okay. Then for them, they will be blessed with the organic chemistry, and they will be happy when we will study the organic chemistry. Although the major part of organic chemistry, in the organic we talk about the reactions, all the carbon related reaction, as I have told you, okay. So that we will be covering in your 12th class. So when you reach in the 12th class, the major portion, like half of your syllabus is occupied with the organic chemistry itself, okay. But obviously if we want to go for the competition, you know that the syllabus for the 11th and the 12th, the combined syllabus will be there, okay. So I hope that we are having the mixed numbers of the students. How many of you are from the JEE and how many of you are for the NEET? Can you please write the number? So how many future engineers we are having and how many future doctors we are having? Just write down the number. Total are the 9 students, right? Just write it down. How many of you have opted the maths and how many of you have opted the biology? You are aware with the IIT, JEE and the NEET, right? These are the competition exams that you will be giving after your 12th class, and obviously for, if you want to get admitted into the good colleges, in the top rank colleges of the India, then you have to sit for the exam, you have to clear it. Okay, very nice. So we have, I guess, the 4 from the NEET. So 4 are the future doctors we are having, and then 5 we are having the students for the JEE. Okay, right. So basically we have the high number for the future engineers, okay. And because I can best tell you about the JEE, I am myself from the JEE background, and I have done the BTech from the NIT Jalandhar, okay, and in the biotechnology branch. So so that is why I am telling you all these things. 7 are for the JEE. Oh, that is great. That is nice. So 7 students are for the JEE, okay. So and good thing is that we are having the 4 number for the NEET as well. So I was just telling you this thing, because for the JEE, you know that you have to be in the colleges like NITs and IITs are there. And like, let me talk about the JEE first. Like, you people have been, many of you already have the idea about these things, and those who don't have, you will get to know about these things, right? So I was just saying that when you opt for the engineering, when you enter some good college of the engineering, then you have a lot of options. You can be the mechanical engineer. If you are interested in making the cars and your related things, then you can opt for the mechanical. These days, the so trendy branch, what is the so trendy branch these days? Anyone? 7 are the JEE students. Let's have the idea from them. Which is the, the ongoing so much trendy branch these days. People are opting for that and people are actually crazy for that. I don't know you people are crazy for that or not. Any idea, Kohima Center? Okay, have you people decided that what you want to join or which branch you are fascinated by? Software, exactly. Yes, Kohima Center. These days, the IT companies are so many there. People are so crazy about the computer science because it's so much booming branch, that we are having these so many companies here related to that. People are going on for their startups. So in every, if you are doing any of the business, obviously you will be requiring the computers here. You will be requiring the screens. You will be requiring the softwares. So we have the huge demand for the software engineers, okay. But apart from that, as I've told you, there are so many, so many chances to explore in the robotics, in the electronics, okay, in the electrical branches also there. And some people will be like me also, they will be from the chemical background or from the biotechnology background. So these are also the branches which you people can opt. So I'm just saying that once you get the good ranks, then you have a lot of options to explore. whatever field you want to go for, you will be getting that. And obviously if you want to, and the important thing is, as you are seeing the trend of the right now, what the trend is going on, we have a lot of engineering colleges in the India. In every state, in every city, we are able to see that so many colleges are there. But the important thing is that good colleges number is lesser, okay. So we have to admit ourselves into the good colleges, okay. When you get into the good colleges now, you are surrounded by, the infrastructure of the college is so much good, you are getting the so much good opportunities, and so many things are there. Let me tell you an example. I was in the NIT Jalandhar. It's a National Institute of Technology. Obviously people do the engineering there, and we have the collaborations with the other NITs also, with the other IITs also, okay. Let's say there is some tech fest going on in the IIT Delhi. Then they used to invite the other colleges, you are free to go over there, you can participate into the, the tech projects over there. Or let's say someone is interested in the cultural programs, then you are invited to the other colleges, and sometimes if you are organizing that particular fest, then the other colleges are invited to your college. So it's a very good program, and you will learn so many things, you will have so many opportunities, you will be, you will be sitting with the other so much good minds, okay. So it's the good thing. Why I'm telling you all these things? Because this is our first class, and the whole, this is a journey actually. You have the 2 years with you, and you have to show much, the dedication and the work hard. It should be very much high, if you want to get admitted into the good colleges. And I'm just telling you that because till 10th, 9th, 10th are the junior classes. The effort which you are putting in till the 10th, till the 9th, that's okay. We really appreciate, okay. That is why you people are sitting there and you people have opted the science. But now, the pace of everything will be increased. You will see so much difference in the chapters. You will see, you are in the higher classes now, okay. So you have to feel it. And in order to feel it, you have to, you have to be focused much more. You have to show your concentrations, okay. So, and regarding the NEET, as we have the doctors also here, I hope you people know that actually you guys have the lesser seats, the seats for the medical examination are quite lesser in number as compared to the JEE, okay. I'm not, I'm not demotivating you, or I'm not scaring you, okay. I'm just telling you, this is the harsh reality we have here. But obviously, once you get admitted into the good medical college, once you are MBBS, then obviously you people will be having the more pay scale as compared to the engineer, okay. And you know that doctor is so much a noble profession that everyone appreciates it, okay. Okay, so you people are excited that you are in the 11th class, or you people are like, we will be having a lot of burden or something like that? It's the different thing. Now I know that when the people switch from their 10th to the 11th, there is some different kind of feeling. You people have that feeling that you are grown up now? Yes, of course. Okay, I'm just asking that whether it's a positive feeling or you are okay. It's the first class. I shouldn't say that. Obviously, it should be the positive feeling. And I'm telling you, it's a journey, and rather than the destination. Obviously the destination is important, but the journey is more important, okay. And that positive approach for the journey, that many times what happen now, we feel, and this happens to you people also many times, when you when you go ahead in your life, then obviously you will get to learn so many things. So many times these things happen that when we feel so low and we don't like anything, or we're irritated or these kinds of things, that is the very important part, that where you have to show your optimistic approach. So obviously when it goes on, you will be keep on learning these things, and obviously when we'll have the classes, you will be having fun, okay. So we will be doing the studies sincerely also, but not in the boring way, okay. So for that, obviously if I am putting my full efforts here, you have to put your efforts as well, right? So I guess I have done with so much of the lecture part. Let's start then. Or anything you want to share, Kohima Center, anything? Or else we can start with the chapter. Okay, nice. So, what is the case here? You know, like, the first chapter is obviously this is the mole concept. Before starting the chapter, although I have written the heading, you people should know about the, you know, at least the 20 atomic numbers, the name, okay? You people know that? How many of you know that? We will start writing from that. The very first one is, any idea Kohima center? I'm saying that you know that na, hydrogen is there, helium, lithium, beryllium, boron. Okay, how far you know that? 20, 10, 30, or ma'am we know whole of the periodic table? I'm just asking that you know the atomic numbers till 10, 20, 30, till 15 you know that. Good, I appreciate that. So let us start, you know, because it's the starting page of your notebook, so we should write all of these things here. So for the first one I'm writing, this is the hydrogen, and you know that the symbol is H. These are fixed, you know, because the Indian scientists will also call hydrogen as H, and the British scientists will also take it as the H. So these are the defined things. Number 2, some are 300, okay 30, I just got scared. 300, we don't even have the elements till 300, good. So helium is there, yes, the symbol is He. Number 3 is the lithium. Those who know quickly, just keep on writing all of them, okay? I am also writing it here, you people just write it down in your notebook. The symbol is Li, and those who do not know them, I am telling you, after this class, once you go home, please learn till 20. We have to learn till 30 although, but for the timing you can just learn till 20. Till 20 we should know the atomic numbers, right? So hydrogen, helium, lithium, then is the beryllium. Then is the beryllium. The symbol is Be. After that we have the boron. The symbol is B. Number 6, your favorite. Anyone? What is the number 6? Okay, just write down the symbol itself. Yes, Kohima center. Very good. So it's the carbon. Number 7. Very good. It's the nitrogen. Okay. So I got the answer for 8th is fluorine. Okay, oxygen. Good. So we have the oxygen, the number 8th. Number 9 is the fluorine. It's the F. Number 10, your favorite, neon. Right? Number 11, sodium. Although it's sodium, but you know that the symbol is Na. Yes, good. Number 12. Number 12, very nice. So sodium is there. After that, we will be writing here as a magnesium. Magnesium is Mg. Number 13, aluminium. It's the Al. Number 14, silicon. Si. Okay, silicon is Si. Yes, number 15 is phosphorus. Phosphorus is P. Okay. Then number 16 we have, what is the 16? It's the sulfur, S. Anyone knows about the 17? You have heard about it. You people sometimes use this also. Number 17. You know that what is the use of this chlorine? You use the chlorine, right? Any idea, Kohima Center, where we have used the chlorine? Have you people used it? Very good. It used to purify the water or kill the germs. Many times in the in the swimming pools, they use chlorine there, okay, in order to purify that water. Number 18, argon. Anything you know about the argon? Which type of gas this is? Anyone, any idea, Kohima Center? Very good. So, it is a noble gas. Neon is a noble gas. Argon is a noble gas. Or you know what are the noble gases? They don't react with the other compounds. Although you will get to know about the exceptions also. There are little bit exceptions that some of the noble gases, they might get react with the oxygen and the fluorine. The very good example is the xenon. Okay, xenon. Xenon is also a noble gas. We will talk about it later on. What I am saying that let's say if I talk about the neon and the argon, generally if I am saying let's say I am reacting it with the water or with the oxygen, they don't get react with anything, okay. So, they are the noble gases, okay. So, number 19 is, anyone any idea? It is the potassium. Potassium symbol is K, okay. Potassium symbol is K. And the last one, who will tell the last one? Yes, tell me. It's the calcium. Very good. So, 20th is the calcium. Ca is the symbol, okay. Right now I am writing till 20 only. Later on we will be studying it till 30, okay. So, those who know till 20, I would request them to learn till 30, okay. Those who haven't known them till 20, just go for it, okay, and at least for the 20 we should know for the time being, but later on we will be exceeding the number till 30, okay. So, 30th is the last zinc, so we will be doing it till zinc, and if those who want to learn more, obviously they can go for it, right. So, you people have written it? No doubt in this one. We have already studied this before. You people have done it in your junior classes. I have just written the 20 atomic numbers, and you know one more thing I want to tell you. If you find any kind of difficulty, anything, you people can write it down, or you can simply write, ma'am, we are not able to understand that. Can you please explain it again? Okay. So, obviously I will do it. Right. So, nice. So, let us start with the another thing. Obviously, this is the first class. We will be first of all covering the basics, because for the mole concept, basic is very important. You know what happened many times when I teach this particular chapter, let's say in the dropper batch, I teach sometimes in the dropper batch, and they people know the formulas and everything. And when I ask them the very small questions, the very conceptual and the basic question, they people don't know that. So, that is why I am telling you, it's very, very important to know about the basics. Okay, just tell me one thing, I am not writing it. You people understand the difference between the atom, molecule and the compound. You understand the difference between these things? Then we can simply do the question. Just tell me, Kohima Center. I have, I've just said the three things. One is the atom, then the molecule and the compounds. You people understand the difference between them, or should I tell you before writing the question? You people know that. Very nice. So, first of all, let's write a question here. And it's a small question. I'm giving you a complete list here, okay. Classify the following. Classify the following into atoms, molecules or compounds. So, I am going to write a huge list here. You people will tell me that, ma'am, these are the atoms, these are the molecules, and the left ones will be the compounds. Okay, so you have to tell me this thing. I am going to write here. Okay, so this is the list, everyone. You have to classify them into the atoms, molecules and the compounds. Quickly do it, you know this. Okay, I got the answer. Hydrogen, helium, oxygen and Fe, you are saying these are the atoms. O2, O3, Cl2, you are saying these are the molecules. Okay. And what about the compounds? Yes, Kohima Center. So you are saying that rest are the compounds. Okay, you want to check your answer for the molecules? Anyone? Your answer is correct for the atoms. You are correct for the compounds. You want to check your answer for the molecules? Or let me explain. See, let me explain, don't worry. See what is happening here. Your answer is absolutely correct for the atoms. You know that what are the atoms? Atom are the single individual atom, you know, like I am saying the hydrogen is a singly, it's not in the combined form, okay. So simple H is written, that particular element is an atom, okay. So you used to call it as the single unit, you know, which you are not able to, which cannot be divided, okay. Although this is the definition according to the John Dalton, and I hope you people know that we can now divide the atom as well. We know that there are the protons, electrons and neutrons. You people know this thing, right? So what I am saying that atoms are here are the hydrogen, this is the helium, oxygen. What is Fe? Any idea about the Fe? Yes, so long, tell me. What is Fe? It's the 26th atomic number, you know this thing. You know what is Fe? Kohima Center. Like which element is Fe? Any idea, or if you don't have the idea, just write down that we don't have the idea. Any student have any idea that what is the Fe? Which element we represent with the help of the Fe? Fe is the iron, right? You know this thing. Fe is the iron. Iron has the symbol of Fe. We used to call it as a ferrous or ferric, na? Like there are so many compounds like ferric sulfate or ferrous sulfate. So iron is actually the Fe, okay. Now what I am saying that the compounds, that answer is also correct, that this NH3, this is a compound, CCl4 is a compound, CH4 is a compound, NO2 is a compound, C6H12O6. Now tell me, Kohima Center, do you know first of all the name of what is NH3? You people know about the NH3? The chemical formula I have written now. What is the name of NH3? You have studied it before. Kohima Center, am I audible to you? Very good. So this is ammonia. Yes. Then why are you taking so much time? This is ammonia. It's a gas. What is this? This is carbon tetrachloride. Carbon, 4 chlorides are there, na? So it's a carbon tetrachloride. You know about this one? What is CH4? You know about this. This is a very famous organic compound. In the organic chemistry, we will talk about it more. Let me first tell you what are these. I am just writing the name, then I will tell you what are the compounds, and then I will tell you what are the molecules. You have any idea of the CH4? Have you studied CH4 before? I guess in your 10th class you have the chapter of that carbon, na? Any idea? Kohima Center for CH4. Any one of you? Anyone? No one? Someone? This is methane. CH4 is methane. It's a gas, okay? So methane is CH4. This is nitrogen dioxide. No need to write the name. We already know that. Like there is the carbon dioxide. So this is nitrogen dioxide. And what is the name of this compound? This I am pretty sure that you know the last one. You use the last one, you know. C6H12O6. What is the name of this compound? Kohima Center. Do you know the name of this last compound? Just tell me if you know the name, and if you don't know even, just write it down, okay? So that I get to know. What happened? I seriously don't remember this. Chat system is not responsive. Okay, I got it. Okay, I am going to write here, no problem. So this is glucose, right? So you know that this is the glucose, this is the formula for the glucose. We were having the methane, nitro group was there, ammonia was there, and carbon tetrachloride was there, okay? So I was just telling you, Kohima Center, the compound is, you know, what is a compound? When you have the combination of more than one element, okay, like you are able to see that nitrogen, hydrogen, everywhere there are the different elements there, nitrogen, hydrogen. So it's the combination. I am just going to write a definition here, okay. So I am going to write here the definition. So you can also write that when more than one type of element combined in a, when they combined in a fixed ratio or in a definite ratio, so that is known as or are called compounds, right? So that is why you have written this as the answer. So in the compounds you will be able to see more than one type of element, okay, more than one type of element, and that will be combining in a fixed ratio. Is it clear, Kohima Center? If your chart system is working, then keep on writing, okay? I hope this is clear. It's an easy thing, you already know this thing, but what I am saying that you people have done a mistake while writing the molecules. Now what is a molecule, you know? A molecule is formed, it may be of the similar type of element, it may be of the different type of elements, okay? It's simply a number, just, you know, let's say I'm doing an experiment and I'm saying that, you know, that Kohima Center just bring me the 10 molecules of the hydrogen. So what you will be doing, you will be obviously taking the 10 molecules of the hydrogen. So I am saying that a molecule is possible for these also, and a molecule is possible for all these also, okay? So all these can be the molecules. So in short I can say that the compounds can be the molecules also, okay? So we can write the definition like that. In the molecules you just want the more than, you know, the number, it should not be the atom, right? A single atom is not a molecule, but we can have either the same type of atoms combined together or the different type of atoms combined together. So if I want to write here the molecules, I will be taking these things also, like from here N2 was there, O2 was there, what else we have taken, O3, you know that this is the formula of ozone, Cl2 will be there. Apart from that I will be writing ammonia also, carbon tetrachloride, methane, nitrogen dioxide and the glucose. So this is the complete answer for the molecules, okay? I'm going to write the definition as well, that a molecule is formed when two or more same or different elements combined, or I can write the atoms are combined chemically. Okay, so I hope with this the difference is absolutely clear with the atoms, molecules and the compounds. Still if there is any doubt you can just write it down and let me know. Clear to everyone, right? Okay, so you people have written it? Done with the writing part? Good. So how we used to, now the next thing, okay, you know the classification, you understand these things. Generally, the representation of an atom. I guess you have done this before. This is a representation, okay. Let me write an example with it. Let's say I am talking about sodium. X is the symbol, okay, that what atom or which element I am talking about. And let's say we used to write 11 here, 11 is the atomic number, we have already written. 23, this is the mass number, okay. So this is a very general notation, you should know that Z is actually the atomic number and A is the mass number, okay. Now we people have written the atomic numbers. Now this is the homework for you, you know, that you people will write that 20 molecules again and you people will write it, you know, you people will write it for the, you people will write for the 20 molecules the mass number. Kohima Center, is there the camera at your center? In front of me there is a screen here and some of the students are sitting over there. Can you please raise your hands? The students from the Kohima Center, can you please raise your hands? Oh, very nice. Kohima, I am able to see you all. So nice this is. Very good. So most of the majority are the boys there. No girl in the class. Seriously. All boys. Okay, okay. 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 That is nice. So I hope you are getting the things, okay? The representation of the atom is clear. This is strange, that we don't even have a single girl there. Why? You studied in all boys school, something like that. You people are like in the all boys school or something like that. Okay, just tell me, all of you are from the different school. Okay. So it's a co-ed school. So you are from the different schools, or all of you are from the same school? Yes, like this is, you are saying that you are from the same school, right? Okay. Okay, different schools, different school. Then, how could it be possible? Not even a single girl is there in the class. I'm just, astonished. Okay. So what I was saying that this is the element written, this is how we represent the atom. And I have written an example of the sodium here, okay. In the similar way, you people will make a table again, and you people will write here the, the mass number and the atomic number, like I am writing for the hydrogen, it's 1H1. So as you have done this, this complete list here, you have written in your notebook, right? So in the homework, do write it like this, like I am writing. Like for the helium, I will be writing He, 2 will be there as an atomic number and 4 will be there for the mass number, okay. If you check the NCERT, you will be able to have all of the mass number there and the atomic number there. So this is the homework, everyone. All of you will write it, okay. You can write the 2 elements here as I have written, and in the similar way, you will be writing all of them, okay. Lithium you have to write, beryllium, boron, all of them you will write. Okay, good, nice. Okay, let's talk about these certain other different things. Now, like, you people have studied this thing that in the, according to the John Dalton was the scientist, that, and he told that the atom is indivisible. You cannot divide the atom, it's the simplest particle, okay. But, the scientists have done a lot of discoveries, and we get to know that we can divide the atom, and there are the electrons, protons and neutrons, right? How many of you know that? Please raise your hands. Let's make the use of the camera, na? How many of you know that there are the electrons, there are protons, there are the neutrons? All of you know that. So intelligent class I have, good. And do you people know that we can even, nowadays if I talk about the recent research, we people can even go into the protons and electrons. Do you know that? How many of you know that? That I'm simply saying that we people can now, obviously not we people, but the scientists have done this thing that, we have done it, like we can go into the electrons and the protons and the neutrons. So we can say that these are not even the basic units. Like you can divide the electrons also, you can divide the proton. There are the certain other, mesons is the word there, quarks is the word there. This is all belongs to the quantum physics and the quantum, all of the quantum part. Don't worry, later on you will study it. Or let's say if any one of you want to go for the PhDs or in the research, then you can go for it, okay. Now what I was telling you, yes, let's write some basic and the fundamental particles. Next heading, everyone. Why we are calling the protons, electrons as the fundamental particles? Because these particles are found in the every atom, okay. Now I am writing here, like let's say I am writing here about the proton. We will be making a table here, okay, because these things we will be using in the different chapters. So it will be, we will be using it in the structure. The next chapter is the atomic structure, we will be using that. So I am writing here mass, I am writing here charge. And obviously now you people have some idea. Let's write first electrons, then neutrons. Anyone? Do you people know about the mass of the protons? Anything, if you want to fill the table, you know anything, I would really appreciate if you write the answer. Okay, how many of you know? Raise your hands. Nobody is raising the hand. We have the camera. Let's make the use of the camera. Anyone, any idea? These are very small quantities, you know that? Okay, let me write it and you have to remember that, okay? So for the protons, you know, the mass is actually 1.6 into 10 to the power minus 27 kg. We are able to see so much lesser the mass is actually 1.6 10 to the power minus 27 kg. And the mass which we have for the protons, the similar is the mass for the neutrons, 1.6 10 to the power minus 27 kg, okay? And you know that many times in the books it is written in the grams also, so you know the conversion factor. In the grams, if I want to write, it will be 10 to the power minus 24 grams, okay? Now for the electrons, we should know for the electrons, it's 9.1 10 to the power minus 31 kg, okay? These are the masses. These are the masses here. Now anyone with the charge, okay, you people might be knowing about the positive and the negative. Just tell me, if you don't know the value of the charge, just tell me the sign. What is the charge on the proton, what is the charge on electron, and if you know about the charge of the neutron. Okay. So you know that for the proton, obviously it's the positive. For the electron, it's the negative. Okay. For the neutron, what is the charge? Very good. So for the neutron, they are the neutrals, okay? They don't have any charge, right? So I am writing the value as well, so you people can also write. Like I am writing here, it's the positive of 1.6 10 to the power minus 19 coulomb. You know this is the unit of the charge, so we can write it as a coulomb, okay? So capital C will be there. For the electron is minus of 1.6 10 to the power minus 19 coulomb, and here you will simply write 0. There is no charge, and this table is important, everyone. We should remember it. Like we, you know, like in the English we say A, B, C, D. These are the A, B, C, D for our chemistry, okay? Done, everyone? So till far we are done with the, you know, the numbers, atom, molecules, compounds, representation we have done, and we understood the fundamentals, the masses and the charges, and the, you know, the number part, right? Now I am writing the next term here. The next term is atomic mass unit. How many of you have the idea that what is the atomic mass unit? AMU is written in the short form, right? Okay, just tell me Kohima Center. Just raise your hands. How many of you know that? Raise your hands. Those who know this thing. Okay, one student knows that. The other also knows that. And the others? Okay. So the name itself suggesting, we are saying that it's an atomic mass unit. So if I want, it's a kind of a unit. Like, why it comes into the significance? Because, earlier what happened is we don't have the instruments to measure the mass of one single atom. You have seen that an atom is such a small, it's so small that we don't even have the instruments to measure the mass. Although nowadays we do have the instruments, okay. But earlier what was happening, we used to take something relative. You know that if I ask you that what is kg, what you people will say? Ma'am, it's a unit. It is a unit to measure the mass, okay. But if I tell you that, the kg, how the trend of the kg started, this is, that there are the 7 units of the dimensions, we talk about them. And kg, like if I want to talk about the kg, there is a cylinder. It's still now, it's present over there in the council, There is a cylinder which the people, just take it as the, the reference point. What the earlier people used to do, I'm just giving an example, no need to write, just look at the screen, okay. Let's say there is a beam over there, okay, there is a beam over here, and I want to find out, let's say at one side, my drawing is not that good, okay, so I have apologized in advance. What I was saying, let's say I want to measure anything, I want to measure any, I have a book, okay, and I have a very heavy book and I'm measuring it. So if I have a book here, and let's say it is equal to the one cylinder. At one side I keep one cylinder, at one side there is a book. So I will be saying I want to tell you the mass of this book. I will say the mass of the book is equals to the one cylinder. Okay, this is the story of actually the kg which I am telling you. Okay, now let's say if I want to measure the mass of an elephant. Okay, if I want to measure the mass of the elephant, and the other side, let's say I have to place, the 100 cylinders like this, okay. So there are the 100 cylinders. After that they will be getting the balance, okay. I have a balance beam. At one side there is the elephant. I have to balance it with the 100 cylinders. So what I will be saying, are you able to see that I am keeping my cylinder as the reference? For the book, I will tell you that one cylinder is equals to the mass of the book. For the elephant, I will be telling you that if you keep the 100 cylinders now, then you will be getting the mass of the elephant, right? Now, every time when I say this cylinder word, it's very difficult, okay? So, I just keep that as a reference that from now, I will be calling this cylinder as 1 kg, okay? That mass of this book is equals to 1 kg and the mass of the cylinder will be, the mass of the elephant will be equal to the 100 kg. Are you understanding that? Same is the case, same is the case with the AMU. Now what happened in this side, like this is the mass which I will, what is the formula for the AMU? 1 AMU, I'm just writing it here, 1 AMU is 1 by 12th of the mass of C12 atom, okay. Now what is this happening, I'll tell you, don't worry. So it's the mass of C12 atom, okay. I'll give you the time to write it down. For the timing, just look at the screen. So 1 AMU is equals to 1 by 12th of the mass of the C12 atom. We have taken, the scientists have taken the carbon as the reference here, because carbon we are finding in the abundant, okay. So, and also its property doesn't get changed so much. So we have taken a very abundant isotope of the carbon, that is the C12. Now, what happened this time? Like if I want to measure the mass of one oxygen, if I want to measure the mass of the oxygen atom. So how it comes to be? It comes to be as that 16 times 1 by 12th of the mass of C12 atom. This what happened actually, okay. Now if I want to find out the mass of the hydrogen atom, it comes out to be, this is all experimental. This is how the scientists have seen it. It comes out to be 1 into 1 by 12th of the mass of the C12 atom, okay. So we have taken a reference as 1/12 into the mass of the C12 atom, and we are getting the different numbers with respect to that. Let's say I am writing here the sodium. If I check here, if I keep that balance and if I want to check for the sodium mass, it comes out to be 23 into 1/12 into the mass of the C12 atom. Okay. Now, it's so much difficult to write the whole process again and again, 1/12 into the mass of C12 atom. So, what the scientists have done, that instead of writing it again and again, why not we call it as a simple unit? So, they just call this whole thing as the AMU. Okay. So, if I want to tell you like what is the mass of a single oxygen atom, it will be 16 AMU. Okay. If I want to tell you the mass of the single hydrogen atom, it will be 1 AMU. If I want to tell you the mass of one sodium atom, it will be 23 AMU. You got the concept? It's a very simple thing. Atomic mass unit is the mass defined for a single atom, just for a single atom. But I am telling you that why this 1 AMU is equal to this particular formula. In your book, the formula is written. So this is why we are writing it. Okay, it's just a reference. Just tell me if this thing is clear, everyone. Just raise your hands, those who are saying it's clear. Yes? Okay, good, nice. So what we can write? You can write from here, okay? I'm writing it again. I'm writing it again. So atomic mass unit you can write, and you can write here 1 AMU is equals to, do write the formula first, 1/12 of the mass of C12 atom. And we can write it like this also. I am writing it again as an example, that if I want for the oxygen atom, it will comes out to be like this. 16 into, everyone just write it down like this, mass of C12 atom, and again you will write it as a 16 AMU. Okay. Let's take one example for the sodium. If you want, you can write for the hydrogen also. I am just skipping the hydrogen, okay. So it will be 23 into 1/12 mass of C12 atom. So it will be 23 AMU. This is the mass of a single atom. Just write down. And if you have any kind of doubt, any one of you, okay, you people can write it down here. And I will tell you in the next step, now I will tell you that if we are having the oxygen, why we are having 16 and how we are having the 16, that I will tell you in the next part, okay. First of all, I have written here the unit, then I will tell you that why we are getting 16 only. Written? I hope everyone is written. Now, you know what happened. Now you are aware with the formula. We are done with the formula. And you got to know that why we used to call oxygen as a 16 AMU, sodium as a 23 AMU, and so on. Okay. Now, this was the earlier case when we don't know about, we don't have the instruments to measure the, the mass of a single atom. But later on, this is now later on. Later on, when we were able to develop those kinds of instruments, then what happened is, now we have the instrument, we put a single mass of carbon, we got the mass there, okay. So when the scientists got the mass of that carbon atom, When they put it here, we get one more value of the AMU. So what I am doing here, 1 AMU is equals to 1 by 12th, and I am putting here, this is all experimental, no need to write these things, I am just writing it. This is in the grams, okay, 1.992 into 10 to the power minus 23, this is the mass of a single atom, okay. Now don't get confused that ma'am, mass of the carbon is 12, that is for 1 mole, I will explain it again, okay. When the instruments were developed, they give us the reading like this, 1.992 into 10 to the power minus 23 gram, this is the mass of a single atom. And you put it here now, you can do your calculation, it will comes around to be like this, 1.6 into 10 to the power minus 24 grams, near about this. And you remember that we have used this value here, look at here, like if in the grams I write it, it's like this one. So 1 AMU is, the value comes out to be the mass of the proton. So this is a next formula which you have to remember. So I am writing here 1 AMU is equals to the mass of 1 proton. This happens when we put the value there and the numerical value comes out to be same as the mass of 1 proton. Okay? Just tell me if it is clear, everyone. Raise your hands, Kohima Center, if it is clear. Okay, good. See, I haven't done anything fancy, it's the pure simple maths I am writing. Right? Okay. So now let's talk about that carbon, let's talk about that oxygen. Now you people will be wondering now that how she has written the 16 over here, okay. Let's clear your query here. Let's talk about the oxygen. Find, obviously it's known, if I give you the simple question, you people will remember the masses, mass number, then you can simply give me the answer. But I am telling you how that 16 comes out. Find out the mass of oxygen atom, single oxygen atom. Now what do you think, everyone? This is the oxygen here, okay, having the atomic number 8. Obviously if I want to find out the mass of the oxygen atom, I have to add the mass of all of the fundamental particles there. Are you with me, Kohima Center? I know that in an atom, what are the things? The protons are there, neutrons are there, and electrons are there. If I add the mass of everything, I will be getting the mass of the atom, right? So can I write it like this? This is simply the oxygen atom. Can I write that how many protons are there? How many protons are there? You know that? In the oxygen, how many protons are there? Very good, it's the 8. And how many electrons are there? This is the actually representation. How many electrons are there? Protons will be equal to the number of electrons, 8 will be the electrons. What about the neutrons? What about the neutrons? You know how to find the neutrons? 16 minus 8. No, Kohima Center, 16 minus 8. The mass number, this, this representation, A minus Z. A minus Z is the neutron. So you will get 8 as the neutrons, okay? So these are the neutrons. So 8 are the neutrons. Just remember them and write it down. Now can you people tell me the mass? You have to add them, na? If I have the 8 protons, I know the mass of 1 proton. So 8 into the mass of proton, okay? We have already written the mass of the one thing. Look at the screen, everyone, I am doing it. Look at the screen. So if I want the mass completely, what I can write? Look at the screen. Can I write 8 into the MP? MP I am denoting just by the mass of the proton. I know the mass of a single proton, so 8 into the MP, okay? plus, can I write 8 into me? This is the mass of electron now. Can I write 8 into mn? This is the mass of the neutron now. You are getting me? Now, look at the screen, Kohima Center, just look at the screen. See, the mass of electron, look at here. Mass of electron is so much lesser as compared to the protons and neutrons. It's 10 to the power minus 31, okay. So, actually we take that as the mass of electron is very, very lesser, you know, we can neglect it. So, what we used to do whenever we used to calculate the mass of the atom, now the electrons are usually neglected because the mass value is very, very lesser, right. So, can I neglect it? So, I am neglecting it. You people, you are understanding that why I am neglecting, because the value is very, very less. It's 0.000000 minus 10 to the power minus 31, right. So, what I can do now, and you know that, look at the screen again, the mass of this neutron and the proton are same. The mass of neutron and proton are same. So, can I replace it with this one, 8 mp plus 8 mp. I am writing mn is equals to mp. You are getting it? It's long. So, this is 16 mp, right? And we know that mp is what? The mass of proton. So, mass of proton, look at here, what is that? That is an AMU. So, can I write it like 16 AMU? So, you got it, that how we are getting 16, right? So, this was the whole process. Obviously, nobody is going to ask you because you will already remember all of the mass number, but at least we should know now that how this is coming out. And in same way, if you want to find out the mass of a single Na, sodium, any potassium, calcium, anything, just go by this method, you will get your masses, okay. So, this is the mass of a single atom. Now, tell me one thing, Kohima Center. We used to say that, already you people know that, the mass of oxygen, you call that 16 grams. Then why, where we use 16 grams? You have any idea? I told you that mass of a single atom is 16 AMU. This is the unit. Then how can we use it as a 16 grams? What is that? Mole. Okay, what is a mole? I got a new term. How many of you know mole? Raise your hands. How many of you know what is a mole? Raise your hands. One student at the back knows the mole. The other people? Okay, I'll tell you. It's nothing, it's easy. It's simply a number. Let's write the mole as the next one. Now, what is in the case of the, the mole is actually, if I want to write here, it's a number, it's the entity. There is a specific number defined for the mole, okay. So, if I want to write, I can also write it like this. If I want to write, I can also write it like this. The mole is 6.022 into 10 to the power 23 entities or species is equals to 1 mole. It's a number because it's so much big na. If I say 6.022 10 to the power 23. So, in order to say it in the short form, I can call it as a mole, okay. I can call it as a mole. Written, everyone? Now, what I am saying, it's like if I am saying that I have, let's say I have 1 mole pens with me. This is the marker, right? I have 1 mole marker with me. It means I have 6.022 into 10 to the power 23 markers with me, okay? If let's say I am saying that the Kohima center where the students are sitting, there are 6 mole classes going on. It means there are 6 into 10, let's say I am saying the 1 mole classes are going on at the Kohima center. It means 6.022 into 10 to the power 23 classes are going on at the Kohima. So, obviously, it's such a huge number, okay. So, like in the daily life, we generally don't use it because it's such a big number. So, we use it for the small things. We use it for the atoms, we use it for the electrons, for the molecules, we use this number. Are you getting me? Okay. So, I am simply writing here just, so that you people will get comfortable. Let's say I am writing that I have, let's say I am writing I have 5 mole apples. What does that mean? How many apples I have? 5 into 6.022 into 10 to the power 23 apples I have. Or there is one more way of notation, everyone. You can write it as 5 Na. Na you can write. Na is the short form like this. Okay. How many of you are getting it? Raise your hands. Earlier your screen was, get stuck. Just raise your hands, Kohima center, if it is clear. Okay, nice, good. How beautiful the world would be, na, if that screen get, if I used to get your voices from this particular screen here. I'm not able to hear you all. Maybe that technology will come, when the people sitting at the other side, they also keep on speaking, and the teacher sitting here side, they will get to know about the things what they are saying. Till far I didn't remember this type of thing is there. Or we are having the, the future engineers here, na? Maybe they people will be building some kind of software, and we will be having this technology, then I will be using it in my class, developed by the Kohima students. That day will come, I pray. Okay, so if I want to write here, let's say if I'm writing I have the 10 mole, let's say I'm writing 10 mole hydrogen atoms. What does that mean? That I'm having 10 into 6.022 into 10 to the power 23 hydrogen atoms. Are you getting me? Or I can write it as I have the 10 Na atoms. Okay? Just write it down. And yes, the question which I've asked you, so everyone just remember it. Like, let's say if I'm writing the AMU here, and let's say if I'm writing here the gram, not even the AMU, let's write it like this. I'm writing it in the note, like, if I am writing that 16 AMU, so this, whenever, this will be written, you will automatically understand that this is the mass of single oxygen atom. Are you getting me? Or if I am writing here that 16 grams, now this is the mass of 1 mole oxygen atoms. Okay, how this is happening, how we are getting 16 again? Look at the screen. We have calculated the mass of 16 AMU. You remember that? So what I am saying, we know that 16 AMU, that the mass of 1 oxygen atom is 16 AMU, right? Okay. So one more thing. Now I need to find out the mass of 1 mole atom. It means how many atoms I'm talking about, Kohima center? It means I'm saying that mass of 6.022 into 10 to the power 23 atoms, okay. Let's say first in my room I was having one single atom of oxygen, and I was telling you that this is the 16 AMU mass. Now I filled the room with the 6.022 into 10 to the power 23 atoms. I have 1 mole atoms in my classroom here, okay. It means I have 1 mole of the atoms of the oxygen, and what will happen? Look at the screen, a simple maths we are doing. So what will I write? I know the mass of one single atom, so I have the 1 mole atom, so what can I write? 16 into 6.022 into 10 to the power 23 AMU, right? You are getting it? Now obviously if I want to convert it into the grams, we know the unit, you know. You are putting now the value of the AMU itself. Everyone just try this. 6.022 10 to the power 23, then 1.6, you know, 1.6 into 10 to the power minus 24 grams. You know, you understand that, na? I have put the value of the AMU. 1 AMU was equals to the mass of the proton, okay? And if you do all that calculation, na, everyone, you will be getting 16 gram as the answer, okay? If you want to try, you can try for the calculation. Once you are done with the calculation, you will be getting this thing. 1.67, you know. This is the very, very important thing, okay, that you should understand the difference between the AMU and the grams. That why, what thing is the AMU and what thing is the gram thing, okay. Any doubt, koi must enter. How many of you are saying that it's understood? Raise your hands. If there is any doubt, you can write it down. Okay, so it's understood. Is that boring? Is it interesting? Okay, how many of you are saying it's boring? What you are writing, ma'am? We are not liking it. Raise your hands. Or might be this time you won't. Yes, it's interesting. Okay. So I hope everyone is liking it, you know. Many times, you know, the student get afraid of it. You know, when I was in the 11th class, when I just entered the 11th class, and obviously the first chapter was the mole concept, I was like, what is happening? I don't know that what was going on. It takes me so much, you know, it takes me at least 1 month to understand the mole concept. I was not good at that, okay. So that is why whenever I teach this particular chapter in the class, now I always ask the students so many times, you are getting the things, you are finding it difficult, is it easy, these kinds of things. And but later on, you know, when you realize, when you actually learn the things, when you are understood with the things, then you find it that it's so easy actually, you know, it's just you are playing with the numbers, nothing else, okay. And the important thing is, once you get the concept, then obviously everything will be cleared and you will be able to solve the questions, okay. So I hope we are clear with the 16 AMU, what is the 16 AMU, and we are clear with the 16 gram as well, okay. So nice. So I am going to write one more formula here for the mole, okay. Many times in the question, you will be supposed to find out the moles. So how you will be finding the moles? The given mass, it means it will be given in the question, okay, divided by the molar mass. Molar mass is nothing, that 16 grams, that is the mass of 1 mole, okay. So that will be your molar mass. Like if somebody asks you that what is the molar mass of oxygen, you will say 16 grams. The mass of 1 mole atoms is the molar mass, okay. Everyone written this formula? And there is one more formula, although I don't, you know, you no need to learn that particular formula, but if you want, you can do it. Mole is equals to, I am writing one more, mole is equals to the number of particles. Don't worry, we will be using it in our numericals, okay, and particularly from the physical chemistry, they will ask you the questions, okay. There is no as such much theory like you people were studying in your junior classes. There will be a lot of questions here, okay. So number of particles divided by Na. These are the two formulas. If you get these formulas, you will be able to solve the questions here. Let's do some questions then, okay? Let's do some questions. You will like it. Okay. Find out the moles. Find out the moles for 80 grams of oxygen atoms. Try it, everyone. Tell me the answer quickly. Find out the moles for the 80 grams of the oxygen atom. Very good, Kohima Center. How many of you are getting 5 as the answer? Raise your hands. Okay, many of you are getting it. Good. So it's simple now. It's the simple application of the formula. Those who are not getting it, don't worry. Look at the screen. Mole is equals to given mass. Given mass is this 80 here. Look at the screen, everyone. Given mass is this 80, which is given in the question. Okay, so 80 divided by molar mass. What is the molar mass of oxygen atom? That is the 16. So 80 by 16. What is the answer? 5. 5 moles. Okay. Let's do one more question. Find out the moles for 80 grams of oxygen gas. Think about it and then tell me the answer. Find out the moles for 80 grams of oxygen gas. Yes, Kohima Center, what will be the answer now? 5 or you are getting something else? Or ma'am, the same is the answer? Yes? Who will write the answer? Okay, who get the answer? Raise your hands. Yes, who will write it? You are getting 5 as the answer itself, or any different answer you are getting? Anyone? Just write it down, and we are just practicing. It's okay if the answer is wrong or anything. You people are doing it, that's more than enough. 5, okay. How many of you are getting the 5 as the answer? Raise your hands. Okay, you are getting 5, okay. Backbenchers are there. You are getting 5. Okay, any one of you are getting 2.5. Any one of you are getting 2.5. Yes, good. See, what was the case now? Look at the screen, Kohima Center. I have given an oxygen gas. Why I have given that? I haven't given you the formula. Always remember, whenever a gas is written, it's a diatomic form. It's O2, right? So your molar mass will get changed this time. Earlier you were writing O as the oxygen and you were taking 16 here, right? So for the one single atom, the mass is 16. But this time, because oxygen gas is written, okay, O2 is written. So here now the molar mass will be 32. That will be 32 grams. You are getting it? So what will be the moles this time? It will be 80 divided by 32. So the answer will be 2.5. This was the only thing, okay? So always take care, like if I am writing nitrogen gas, N2 will be there. If I am writing hydrogen gas, H2 will be there, okay? So just take care for this thing. The two boys, those who are just sitting in the front, you people got it right? Raise your hands if you got it. Okay. So I hope everyone got it. There is no doubt, okay? That is why I am saying now that when we practice a lot of question in the molar, it's very, very important to practice a lot of question, because every time the question can be differently framed. So once we do a lot of practice, then you will be comfortable with solving the questions, okay? Let's do one more. Find out the moles. Find out the moles for 88 grams of CO2. CO2, you know that it's a carbon dioxide. And if you don't know the masses, let me know, I'll tell you the masses, okay? You have to find molar mass by own. That is why it is very important to learn the atomic numbers and the mass numbers, okay? Just try. Okay, just tell me what is the molar mass of the CO2, Shillong Center, oh sorry, Kohima Center. I am in the process of taking the lot of classes with the Shillong, so I get habitual with saying Shillong because we have the camera at the Shillong also. I am so sorry. So, what is the molar mass we are getting for the CO2? Anyone? No one? Someone? Very good. So it's the 44, right? So obviously it's the 44. Those who are not comfortable in finding the molar masses, let me write here, you know. For the carbon, it's like 6 and 12. Although these days in the JEE and the NEET exam, the molar masses are given, okay. So oxygen is there, so it's 8 and the 16. But I'm telling you, at least for 20, you should remember this thing, okay. From here you will get the molar mass. So if this is the CO2, everyone look at the screen. So for the carbon it's 12, for the oxygen, for one oxygen is 16, for 2 it will be 2 into 16. So you will be getting 12 plus 32, so 44 is the molar mass, okay. Now you need to find the moles. So the moles will be, the given mass is 88 and you will divide it by 44, you will get the answer as 2. How many of you got the answer 2? Raise your hands. Okay, many of you got it. Very nice, very good. Okay, then let's do one more question. Find out the moles. Find out the moles for 198 grams of sulfuric acid. I am not writing the formula. You people know the formula, right? You have heard about the sulfuric acid. It is the king of all of the acids, a very strong acid. Try this one. Now you people will get stuck for the sulfur. I am writing few things here. Hydrogen is 1H1, oxygen is again 8 and 16. I am writing the molar, the masses here. The molar mass of sulfuric acid, you have to find it out by your own, right? Sulfur is 16 and 32. These, the above one written are the molar masses, right? These are the molar masses. Don't get confused. Yes. What is the answer? What is the formula for the sulfuric acid? You people know that, right? H2SO4 is your sulfuric acid. So first of all, you people have to find out the molar mass of sulfuric acid, okay? And then the given mass is there, then you can put it into the formula, you will get your answer. What is the mass you are getting, everyone? Oh, let's make your calculation bit easier. Everyone, just take it as 196, na? Take it at 196. I'm so sorry. This will make your calculation easier. Yes. Yes, very good. So, how many of you are getting 2 moles as the answer? Raise your hands. Okay, many of you are getting it, very nice. So, H2SO4 is there. So, first of all, we have to find the molar mass, okay. That is why again and again I am saying that remember the masses, right. So, 2 into 1, one hydrogen has the mass of 1H1, you remember that, I have given it also in the question. So, 2 hydrogens are there, so it will be 2 into 1 plus sulfur is 1, so it will be like 32 plus 4 into, because 4 oxygen atoms are there, 4 into 16, when you combine them you will get 98. And you know what happened is, when you many times solve these specific questions, some of the molar masses you will easily, like I always remember H2SO4 is 98, calcium carbonate is 100 and NaOH is 40. So you will also learn them, okay, because when you solve a lot of questions there will no need to do the calculation again and again, okay. So the moles will be 196 divided by 98, I will get 2 as the answer. So what is the answer? 2 moles, okay. Okay then, excuse me, we are done with this question. Let's do some more questions. Let's do some different type of, okay. This time what I am giving you, let's say, find out the moles for 6.022 into 10 to the power 25 atoms. 25 atoms of hydrogen. This time I haven't given you any mass or anything, so obviously there will be no use of that mass formula. I have given you one more formula, apply that. A number is given to you and you know, okay, just try by yourself, then I'll tell you. Yes, what is the answer you are getting, Kohima Center? 100. How many of you are getting 100 as the answer? Tell me, raise your hands. Okay, good. So 100 is the answer, right? There are the two ways to do this question, either you can simply put, just check at the screen. This is the formula we have. Whenever the number of particles is given to you, like this time for the atoms are given to you, you have to find, that 6.022 into 10 to the power 23 atoms combine and form a 1 mole. This time how many atoms we have? So either I can put it into directly the formula like 6.022. This is the given entities, 25 divided by Na, 6.022 into 10 to the power 23. You know this thing that this will get cancelled out, 10 to the power 25, and when you take the powers above, it gets subtracted. So 100 is the answer. So this is the one thing, direct formula. Now many times students do not go for this formula. Then what you have to do? Look at the screen, everyone. A simple unitary method you people have studied in your 9th class. That 5 people are able to do this work in 10 days. Then 2 people can do this work in how many days? These types of questions in the maths we used to do, na? So similar kind of thing. What I can write, I want to find the moles. So the thing which you want to find out, keep it on the right hand side. I am telling you the second one. One thing is clear, you can apply the formula, but let's say you don't remember the formula. Then simple unitary method you can apply. 6.022 into 10 to the power 23 atoms. They mean that we have a 1 mole, right? Then 1 atom, for 1 atom how many moles are there? You know that you will be dividing it. 1 divided by 6.022 into 10 to the power 23. If 1 atom is this much mole, then 6.022 into 10 to the power 25 atoms. How many moles? You will multiply this time, okay? So 6.022 10 to the power 23 multiply by. Basically we are getting the formula again, okay? So this is the another thing. This is a simple unitary method. You got it? Kohima Center, raise your hands, those who are getting it. Any doubt? Is it easy? Okay, those who are saying it's easy, just raise your hands. The other people? The other people are not raising their hands. I don't think so, it's tough. We haven't done the tougher questions yet, So these all things are the easy right now. And whenever you get stuck, or whenever you are like, ma'am, this is so tough, we are not getting it, just feel free to write it down, okay? I'll try my best to make it easy, right? So, okay, let's do one more question then. Find out the moles for 12 into 0.04 into 10 to the power 20 molecules of water. Similar kind of question this is, as we have done above, okay? Try this one. This time we have given with the molecules only. Apply the same thing, you will get the number of moles. Yes, what is the answer? Kohima Center. So what is the answer? Tell me, na, what is the answer? It's a similar thing this is, The number of particles are given to you. It can be the number of atoms, it can be the number of molecules depending what is the species there. Like in the earlier question, only the hydrogen was there. So obviously they will be asking for the number of atoms, okay. This time I am talking about the water. So obviously I will be talking about the number of molecules. Put it into the formula, get your answer, tell me what you are getting. Yes? How many of you got the answer? Okay. Some students got the answer. So what is the answer you are getting? You want to type? Come forward, write down your answer. Yes, the student at the back, he got the answer, right? Why don't you come forward and write down the answer? Yes, come forward. And those who are getting difficulty or not getting it, I will solve it, okay? Yes, what is the answer you are getting? 2.0 to 10 to the power minus 3. Yes, this is correct. Good. See, so what we have to do, this is the mole. Yeah, I am applying it into the formula, right? So it's like the given entities, the given number is 12.04 10 to the power 20. I just play some trick with this number, okay? I have just changed some of the instead of giving 23 or anything, I have written 20 here. So the below it will be 0.22 Avogadro's number you have to write here, okay? It's 23. Now everyone, see na, many times when you see this type of thing, try to cancel it out, okay? Don't go for the complete calculation. No need to do that. It's 6.02, it's 12.04. Just cut it out with the 2, okay? So if you multiply 6.02 with the 2, so what you will be getting? It's simply, okay, 12.04. So just cut it out with the 2, okay? This type of rounding off you can do by your own. And what will happen over here? It's 2, or even if you want, you can write 2.02, okay? Either I am using only the 2. If you want, you can write, that is also correct, which the student has written. 10 to the power minus 3, because this unit will go above. So 10 to the power 20 minus 10 to the power 23, you will be getting this. This is the answer. And if I want, I can write it like this, 0.002. This is the answer. Getting it? Kohima Center, any doubt? All of you are getting the answer now? Should we do more questions? Okay, so I hope there is no doubt, everyone has done it. Those who are saying it's clear to us, please raise your hands. Those who are saying it's clear to us, just raise your hands if it is clear. Okay, so it's clear to everyone, right? Good, good. Let's do one more question. find out the moles and number of molecules for 500 grams of calcium carbonate. You know the formula of calcium carbonate? CaCO3. This is the calcium carbonate, okay? Now I am giving you, this time the mass is given, okay? So take care, Kohima Center, the mass is given to you. You have to find the two things in this question. You have to find the moles also, you have to find the number of molecules also, right? So first of all, you can start the question with finding the moles, okay? And you know that the mass is given. For the molar mass, you will be, you will be supposed to calculate the molar mass. So for your convenience, I am giving you here. Calcium is 40. Calcium having the mass of 40. Carbon, you know that it's 12. Oxygen, you know that it's 16. Try this question. So what is the answer? Oh, I got the answer. Very nice. So how many of you got the 5 moles? Raise your hands. How many of you got the 5 moles? Raise your hands. Many of you got it. Good, nice. So intelligent class. Either I am teaching you so in a very good way or you people are taking it in a very good way. Okay, I am just kidding, okay. Nice. It's an easy thing, obviously the 5 moles will be the answer. Then what about the number of molecules? You got the number of moles, then what will be the number of molecules? 1 mole has this much, and Avogadro's number of molecules, you know that, okay, that 1 mole having 6.022 into 10 to the power 23 molecules. So what will be the amount in the 5 moles? Just calculate it, tell me the answer. Meanwhile, those who didn't get for the CaCO3 moles, just look at the screen I am solving. So first of all, we will be finding the molar mass, right? So molar mass for the CaCO3, it will be 40 plus, although it's 100, okay? So do remember it also. 12 plus 3 into, it's 48. 16 into 3, na, it's 48. So you will be getting 100 grams as the molar mass, right? So if you want to find the moles, it will be 500 as the given mass, 100 will be below. So what will be the answer here? So what will be the answer here? The 5 moles will be the answer. Now the next part. Yes, what is the answer? The next part is also very easy. See, everyone, look at the screen. 1 mole contains 6.022 into 10 to the power 23 number of molecules. Yes, very good, Kohima Center, this is the answer. So 5 mole contains how much amount? It will be 5 into 6.02 to 10 to the power 23 molecules. So what is the answer? 30. Okay, you people have done the calculation, right? Into 10 to the power 23 molecules. How many of you got this as the answer? Raise your hands, Kohima Center. How many of you got it? Good. Okay, many of you got it. Very nice, very good. So I guess we are done with the class timing now. You want to do more questions? See, if you want to do, I would be happy. I can write some more questions here. Oh, no, ma'am, we just want to go home. Done with the today's chemistry. So I hope you like the lecture, right? And there is no difficulty. You don't find anything difficult, because you know what happened. This is the very first chapter, I understand, and most of the, like in the mole concept, they never ask you the question from the theory. They will always ask you the question for the numericals, and you will see the application of the mole concept. Now I am telling you, it will be there in all of the further chapters of the physical chemistry of the 11th also and of the 12th also. So it's very, very important to understand all of the concept right now. Otherwise, you people will suffer like me when I was in my 11th class, okay? That it will be taking a lot of time, like 1 month for understanding it. And whenever you see, because you know what happened is, this is the psychology we used to make, that sometimes when the people used to get scared a lot from the mole concept, then whenever they see that word of mole, let's say in any other chapter, na, they just skip that question. They just leave that question, you know. They don't even do that. So we don't have to do it, right? So you have any kind of doubt, anything, Kohima Center, feel free to write it down. Or I'm thinking that let me give you 1-2 questions for the homework. Okay, that whenever we are having the next time class, we will discuss that question. And I hope you, all of you are there in the WhatsApp group, right? So all of you are there in the WhatsApp group. So we will be, you know, you people can share your answers there also. So I'm writing it here. Find out the moles and the number of molecules for 51 grams of ammonia. One more question, okay? Only 2 questions I am giving you. Find out the number of molecules this time I am giving you 2 things, okay? Find out the number of molecules and the total number of atoms. Total number of atoms. 2 things I am giving you, okay? The second one question is something different one, okay? You people can try. Then if you will not able to do that, then we will discuss obviously in the class. This is find out the number of molecules and the total number of atoms for 2 moles of glucose. So you people know the formula, right? C6H12O6, and ammonia, again you know that this is NH3, right? So I have given you 2 questions for the homework, and one thing more I have given you. That table you have to complete, the very first one, right? You have to write the molar masses of the 1 to 20 elements, right? Okay, so these are the 2 questions. Just look at the screen, Kohima Center, and try to complete that table, okay? Because it will be helpful for you, na? That let's say whenever you are searching for the masses, then you don't have to look here and there. Okay, so it would be good if we write all of the atomic numbers and the atomic masses at the very first page of our notebook, right? So this we have to do that. And okay then, so we will be doing some more questions in the next class. That is it from my side today. So see you in the next class. If you find any kind of difficulty, Kohima Center, any problem you have, you can message me on the WhatsApp group. I am there in the group also. And try to make the good use of that group, you know, we can have the discussion over there. And these are the 2 questions. I will look forward to see your answers in that WhatsApp group, right? Okay then. You want to say anything? You want to write anything? Any doubt in the today's class? Or no ma'am, we want to go home. We have done a lot of things. We have studied a lot. Anything? No? You used to speak so less. Okay, don't worry. As the time will go on, I hope all the shyness will go away. Okay? Okay then. Whenever you are going home, just revise the formulas of the mole concept. Okay? Okay then. See you in the next class. Bye bye. Thank you so much. See you in the next class.